Hi class, this is a recording of the solutions to the exercises on page 251. We wanted you to do this after the quiz on Friday, and it's going to be a good prep for what we're going to be doing later in chapter 5. Number 1, graph each value on a number line without using your calculator. Let's go ahead and do the first one, the square root of 11. And that's going to be somewhere between, if we think about it, the square root of 9 would be 3. The square root of 16 would be 4. So the square root of 11 is going to fall somewhere in between there. And since 11 is closer to 9 than it is 16, I think it's going to be a little bit closer to 3. So right about in there. B, the square root of 47. Let's do that one in red. Square root of 47 is going to be pretty close to 7 because the square root of 49 is 7. So the square root of 47 will be somewhere right before you get to 7. 7 squared is 49. So something a little bit less than 7 squared will be 47. Square root of 55. Now 55 is larger than 49 but smaller than 64. 49 and 64 are the two closest perfect squares to 55. Since 7 squared is 49 and 8 squared is 64, the square root of 55 will land somewhere in between. Let's see, somewhere around 7.5, I guess. So let's just put it right in there. All right, and finally the square root of 67. So we're just estimating here. 67 is slightly larger than 64, so I would anticipate that the square root will be a little bit larger than 8. Square root of 67, a little bit larger than 8. So that's where those 4 square roots will land if we estimate them on a number line. Number 2, rewrite each expression with the smallest possible value inside the square root. Let's do this one down here at the bottom. Number 2, we have the square root of 24. What we do with this is we try to break 24 up into 2 factors, one of which would be a perfect square. 24 can break down into 8 times 3, 6 times 4, 12 times 2. I think 4 times 6 will be the key here because 4 is a perfect square, and you can square root 4 to get 2. So 2 comes outside from under the square root, but the 6 is stuck underneath. What you can do to see if you did this right is you can enter into your calculator the square root of 24 and see what decimal that is. And then you can enter in 2 root 6, 2 times the square root of 6, and see if you get the same answer, and you should. For B, the square root of 75. So we want to think about how you can break 75 up into 2 factors, one of which is a perfect square. I know that 75 is a multiple of 25. It's actually 25 times 3. Think about money. If you had 3 quarters, you would have 75 cents. Now, 25 is the key here because it's a perfect square. And we can take the square root of the 25 part, and that comes out as 5. So the square root of 25 is 5, but the square root of 3, that factor remains under the square root sign. Square root of 45. We need to break 45 up into 2 factors. Let's see, 45, you could do 9 times 5. You could do 15 times 3. We're searching for a perfect square, and I think we actually already found it back here with 9 and 5. So the square root of 45 will break up into the square root of 9 times 5. The square root of 9 we can do. So that's going to be the key, square rooting that 9 to get 3, and the square root of 5 stays underneath. For the square root of 40, you're going to break that up into 4 times 10, so that one's going to be 2 root 10. The square root of 300, 300 is 100 times 3. The square root of 100 is 10, but the square root of 3 stays underneath. Okay, matching equivalent values in number 3. We have number 3a, which is the square root of 12. 12 breaks up into 4 times 3, and the square root of 4 is 2. So I think little a matches I. 2 times the square root of 3. Next, we have to connect it with one of these capital letters A, B, C, D. Do we think that the square root of 12 is somewhere between 2 and 3? Well, you want to think that 2 squared is 4 and 3 squared is 9. So I don't think this is the right answer. Somewhere between 3 and 4. 3 squared is 9 and 4 squared is 16. So I think B is the good one there. So I think little a matches 3, which matches capital B. 3 root 2. Now we're doing this one a little backwards. 3 root 2. If we think about it, if this 3 wasn't square rooted yet, if this 3 would have been underneath that radical, it would have been the square root of 9 times 2. 9 times 2 is 18, so I think this matches little I, or number 1. The square root of 18, I think, is somewhere between 4 and 5, because 18 is higher than 16, but smaller than 25. So I think little I matches C. Next, we have the square root of 28. 28 can break up into 4 times 7. The square root of 4 is 2, and the square root of 7 is stuck. The square root of 28 is going to be a little bit larger than the square root of 25. So I think it's somewhere between 5 and 6. So I think we match up on the bottom here. C matches 4, matches D. And finally, for part D, 2 root 2, that's going to be the square root of 8, because if the 2 was still under the square root, it would be the square root of 4 times 2, which is the square root of 8. And that's going to be a number between 2 and 3, because the square root of 9 is 3, so the square root of 8 is slightly smaller than that. Finally, we have a greater than and less than signs. Just going to go through the answers here. We have greater than for A. Square root of 17 plus the square root of 27 is greater than the square root of 17 plus 27. If you do these individually, you're going to get a larger number than what you would get if you square root their sum. Okay, the square root of 30 minus the square root of 10, that's actually the other way. So that less than, it's going to be less than. 8 root 5 is larger than 5 root 8. Think about it this way. If that 5 was under the square root, it would go in there as a 25. So it would be 8 times 25. If that 8 was under the square root, it would be 64. 5 times 64 is a lot bigger than 8 times 25. So this guy's definitely larger. And finally, for D, it's going to be less than going this way. The square root of 6 squared is 6. The square root of 11 squared is 11. So that side we get 17. And on the left side, 6 squared is 36. 11 squared is 121. If we add these together, we get the square root of 157, and that is a lot smaller than 17. The square root of 100 is 10. The square root of 121 is 11. The square root of 12 is the square root of 144 is 12. So this is definitely going to be less than this way. 17 squared is a lot bigger than 157. That concludes the answer key for page 251. Hope you enjoyed it. See you tomorrow.